Ever wonder what actually happens in the milliseconds it takes to open a website? Every click triggers a massive, invisible system of computers, protocols, and networks working together. Today, we'll break it down step by step from your device to the server and back. You type example.com into your browser. The first thing your browser does is split the URL into its components: the protocol, which is usually HTTPS, the domain name, like example.com, and the path, such as home. Next, your computer checks its local DNS cache or browser cache to see if it already knows where to go, avoiding unnecessary lookups. Then the browser prepares an HTTP request. This includes headers like your user agent, accepted formats, and any cookies needed for authentication. At this point, your device is ready to resolve the domain into an IP address so it knows exactly where to send the request. DNS, the domain name system, is basically the internet's phone book. And curious, your device asks a recursive DNS resolver, what's the IP address of www.example.com? If the resolver doesn't have it cached, it queries a chain of servers. First the root DNS server, then the top-level domain server, in this case the .com server, and finally the authoritative server for example.com. The authoritative server for example.com. The authoritative server responds with the IP address, something like 93.84.21634, determined. This process takes only a few milliseconds, but it's critical. Without it, your device wouldn't know where to send your Next, your device connects to the server using TCP switch IP, which is the backbone of the internet. It starts with a three-way handshake. Your device sends a SYN packet, the server responds with SYN ACK, and then your device sends an ACK. Just like that, the connection is established. If the website uses HTTPS, TLS encrypts the connection. During this handshake, encryption keys are exchanged, and the server's certificate is verified, keeping your data safe from eavesdropping or man-in-the-middle attacks. Now your browser sends a fully formed HTTP or HTTP2 request. For example, the GET request for index.html, including headers like host, user agent, accept and loading, and cookies. Modern protocols allow your browser to send multiple requests simultaneously over the same connection, which makes everything faster. The server receives your request and starts processing it. First, it routes the request to the right application. For example, a web server might forward it to backend software like Node.js, Python, or PHP. Then it generates a response, fetching data, rendering HTML, running JavaScript, and preparing CSS and media files. Before sending it back, the server breaks the response into TCP packets. Each packet has headers with source and destination IPs, sequence numbers, and checksums to ensure data integrity. Those packets then travel through a complex web of routers, switches, and gateways. Routers decide the fastest path for each packet. Paths can vary, so packets might arrive out of order, but TCP reassembles them correctly. Packets travel through multiple layers: the physical layer, like fiber optics, copper, or wireless; the data link layer, using Ethernet or Wi-Fi frames; the network layer, using IP addresses for routing; the transport layer, TCP or UDP, ensuring reliable delivery. The Internet's routing system is decentralized and resilient. If one path fails, packets simply find another. When packets reach your device, TCP reassembles them in the correct order. The browser then parses and renders the content. HTML becomes the DOM tree, CSS forms the CSS OM tree, and JavaScript is executed. These together create the render tree, which your browser displays as pixels on your screen. All of this happens in milliseconds, giving the illusion that the page appeared instantly. To make everything even faster, websites use optimizations, content delivery networks, or CDNs. Cache static files closer to users geographically. Browser caching stores images, CSS, and JS locally. HTTP3 and Quick use UDP for faster, more reliable delivery, and compression technologies like gzip or broadly reduce file sizes. So the next time you open a website, remember, hundreds of invisible processes are happening in the background: DNS lookups, TCP and TLS handshakes, routers forwarding packets